Welcome back. In this video, we're going to look at net ionic equations, and we're going to take it from essentially a metathesis reaction, which is a double displacement reaction in which you get a precipitate. So we're going to start with two aqueous solutions. So these are probably colorless solutions to where everything, all the salt is dissolved in the liquid, and this is aqueous, so the liquid is water. So we're going to have a solvent, water solvent, with a salt, a lead nitrate salt, dissolved in it, completely dissolved, and then a sodium sulfate salt. Okay, because there's very many salts. So the salts are anything that can completely dissociate. So it dissociates, remember, it breaks apart into ions. So the lead is going to be an ion, nitrate will be an ion, the sodium will be an ion, and the sulfate will be an ion. Now, the first thing we have to do is this is going to be a reaction. So these are the two reactants. This is what's going to react together. You're putting this and this in a test tube together. So we have to now, first of all, predict what are the results or what are the products of this reaction. Well, what you see is that you've got a cation here. This is a plus, and this is a plus. This is a minus, and this is a minus. So you're going to have two cations and two anions, and when they're put into the water, they're going to completely break apart. The lead will break apart from the nitrate, the sodium will break apart from the sulfate. If lead and nitrate come back together, if they happen to just touch and come back together and form a product again, they're just going to break apart again because they're aqueous. That means they dissolve in water. So if they were to come together again, they just dissolve back again and nothing happens. But if this lead, if we were to put lead here as the cation, and it comes in contact with the sulfate, okay, lead sulfate, this happens to be, if you remember, all sulfates are soluble, but lead is an exception. Lead was one of the 6 exceptions of sulfates, soluble sulfates, so this is a solid. So if lead actually comes together with sulfate, it's a solid. Now sodium would then come in contact with nitrate. Now the first thing that we're going to have to do is see if this is actually the formula for this molecule. Sulfate, if you remember, is a -2, and lead would have to be a +2 in order to balance. So let's look and see if that was a lead 2. Let's come back here. Nitrate, remember, is -1. So there's two -1s, so this is a -2, the anion is -2, and to balance with that, that would have to be +2. So this is lead 2, and so this is lead 2, so you don't have to do anything. This is 2, +2 and -2. Sodium is +1 because it's in group 1. Nitrate is -1, so this is -1, +1, so this doesn't have to be fixed either. So the first step after we find out what the products are going to be is we balance everything. So let's look at lead first. Lead and lead is fine, nothing there. I have two nitrates, so I'm going to have two nitrates here, so I'm going to have to put a coefficient of 2 in front of the sodium nitrate. And now let's see, because that might mess up my sodium. I have two sodiums. So I'm checking over here, I also have two sodiums. That's fine. I have one sulfate on this side, one sulfate on this side. So this is a balanced equation now. This is called the molecular formula, or molecular equation. Molecular equation, because an equation, remember, you're going to have reactants and products, and it's balanced. And these are all the molecules that you're going to have. That's a molecular equation. The first thing we're going to do here is we're going to break everything up that's aqueous, okay? This is aqueous too, because all nitrates are soluble, so this is aqueous. Remember, aqueous means it's soluble. So all the aqueous compounds, we're going to break it apart. So this is aqueous, so we're going to see that this is lead 2, so that's +2. And we're going to have two nitrates. So we have 2 NO3, and that's -1. And then remember, all this is aqueous, so this is going to be broken apart in the water. I've got two sodiums. So I'm going to have two sodiums, and remember, sodium is +1. And then I'm going to have a sulfate, and sulfate is -2. Over here, I'm not going to break anything apart because it's not aqueous. It's solid. So I'm just going to leave this the way it is. So this is lead sulfate. And I'll say again that that's solid. This is aqueous, so we're going to break it apart. We're going to have 2 sodiums. And this is 2 molecules of sodium nitrate. So there's 2 sodiums and 2 nitrates. So sodium was, remember, +1, and then 2 nitrates is -1. This is called the complete ionic equation. Okay? It's an ionic equation because it's all the ions. This is an ion, this is an anion, this is a cation, this is an anion, this is the solid, this is a cation and an anion. So this is complete, meaning everything that's there is recorded. That's why it's called complete. But really, if you're going to see what did I actually make, I made lead sulfate. That's the only thing I made. Everything else is simply floating in the water. Nothing. It's not making anything. This is the only thing that's made. What made lead sulfate? Well, lead made lead sulfate, and sulfate made lead sulfate. Everything else is going to be an ion on both sides. This is called a spectator ion. And if you see, I've got 2 nitrates on this side and 2 nitrates on this side. I can strike those out. They don't make anything. They're simply floating in the water. I also have 2 sodiums on both sides. Those are spectator ions. They float. Okay, they're not making anything. When whatever I have left over is what actually made my product. And this is the lead 2 plus sulfate, SO4 2 minus, and that yields lead sulfate, which is solid. This is called the net ionic equation, because this is what's left over after everything else that was a spectator was taken out. This is actually the equation that was made when I put lead nitrate and sodium sulfate in the test tube. What am I making? Lead sulfate. What made it up? The lead ion, the lead cation, and the sulfate anion. So you've got 3 things. You've got the molecular equation, the complete ionic equation, and the net ionic equation. I hope this helps you. Watch as much as you need to. See you in class.